What does save chat do? Oh, it actually just saves the chat as a text file. Okay, well, whoops.
Save chat. How is the web lab going this year so far?
Going pretty good. I think we're getting good turnouts and people are making cool projects. So we're excited.
I think this is our highest number of actual students and teams that we've had of all the years.
Okay.
That
Wow. How many teams are there?
the teams that completed milestone 1 was around 180 something.
Whoa. And how many are like just one person team versus multiple people in a team?
I would have to crunch those numbers, but
Okay.
probably an okay chunk, maybe like a 20 to 30% were probably one person teams if I had to take
Really?
a
Many?
guess.
I would say more.
I think it's a pretty high number
Okay.
of one person teams.
Okay. That's very encouraging. And given that it's the first time that you're doing it online, like completely virtual, right? There is no one. Yeah, that's commendable. Good job.
Thank you.
Alrighty. I think it's 10:05 and we still have a couple students still joining the call. We can just get started. So today's actually, A, it's our last day of lecture, which is, pretty quick, pretty exciting. But B, this is also the last sponsor lecture we'll be having this week. So today we're actually joined by MIT Open Learning. So Anindya is here from MIT Open Learning, and he'll be giving our presentation for today. And then if you have any questions along the way, feel free to ask. And then after that, we'll move on with lectures. But yeah, I'll pass it over to you.
Thank you. Thank you for having me. And I am impressed that so many of you could join me today afternoon. And so just to give an overview of this talk, it's probably a little less techy compared to some of the other talks that you have been hearing. But I do mention that near the end, I would talk about the one category prize that we have from Open Learning, which is about developing apps on Canvas and Canvas LMS. And that's something that we have a $1,000 prize just for that. So we would definitely want you to stick around. But this talk, we would start with a survey on data economy, which could be a new term for many of us, although we are kind of, we are aware of what that entails. Um, so, so this is part of a research project, and you don't have to take the survey if you don't want to, and you definitely should not take the survey in case you are below 18 years of age. And it's completely voluntary. It has like absolutely nothing to do with your grades or your participation in this course. Me and a colleague of mine, Aaron Kessler from Open Learning, we are looking at this data to understand how people, and especially young people, uh, think about data privacy and participating in data economy. So uh, your participation definitely helps us with understanding that, and it's an emerging area and we don't know much about it. And this understanding helps us, how we shape tech for the future. So with that, this is the definition of data economy that we get from Wikipedia. And I would give you like 10 seconds to take a look at that. And also, anytime, if you want, you can ask questions, even like during the survey. I would try to answer that by chat. Um, and and yeah, generally during the talk, feel free to stop and ask questions. And yeah, I encourage that. So with that, we would have the survey on for about 10 minutes, and usually people take about 5 to 7 minutes. Last year, that's what the average was, about 5 minutes. So you can take the survey in peace and then come back, and then we'll continue with the rest of the talk. So here's the outline. We would have the survey, and then I would share some insights from the last year's survey. That's a very good question. Where is the survey? It should be in the next link. Let me see. Oops, hold on. Can you guys see the survey? Now the question is, where is the, oh.
Yeah, I can send the short link right now. It's web.lab.
The short link is actually the
a different short link. Yeah.
Yeah, we just created like one for the survey.
Awesome, excellent.
Yeah.
Thank you so much.
Mm-hmm.
Yeah. All right, so now the time is 10:10, and in case you're having issues accessing the survey, do let me know. But otherwise, it'll be on Qualtrics, and you don't need MIT certificate to access that. And it's we should touch base on 10:17, 18 or something. All right. So I think we have probably given enough time. Uh, raise your hand, raise your Zoom hand if you think you have got enough time to complete the survey, or do you think we should wait for a couple more minutes? What do you think? Okay. All right. I see many hands. Okay, so I guess it's good to move on, and the survey link would be open. So if you want to go back to it, finish it, share it with your friends and classmates, it's fine. It's open. It's anonymous, and especially like if they're MIT students, if we know from them about how they think about this, that would be great. And maybe we'll close the survey in a couple of days. So within that, if you have a chance to get more respondents on that, that would be fantastic. Okay, so now that we have a fair bit of an idea what the survey was about, this is actually the second year that we are giving this survey, and we had that in web lab the last year, and we got some results which were fairly interesting to us, and we thought that, of course, the results this year could be different from the last years, but at the same time, our thinking does not change that fast often. So I thought I would share what we learned from last year, some of the, a couple of highlights, and thought that you would enjoy. You might have what your predecessors have answered last year. So we did this survey, analyzed the data with my colleague Aaron, who is also at Open Learning. And so one main thing that we see is that this question of how the level of comfort for sharing general data with different for-profit entities. And we have all these different types of data. And we see that here in this particular plot, that we have different percentage of uncomfortable to comfortable relation, and we see that it's actually the educational data people were most comfortable sharing, which was kind of surprising given that it actually has a lot more protection. Like if you think about FAIRPA and compared to, let's say, financial data, which is for example, our credit card transaction data are brokered and sold in various ways. So that cannot happen with our educational data, but we are a lot more sensitive about it. And that kind of shows how the privacy protection that we have in place are very different from one type of data to another. And our perceptions are often very different from one type of data to another. Also, I just reiterate, like many of these things, these are ever changing. If you have any questions, concerns, feel free to put your question on the chat so that we all can see and discuss. The other question that you answered, and here we see the results from the last year's survey. The comfort of students for sharing educational data with various campus entities and other educational, maybe third-party apps, third-party areas. And this is the net percentage of people being okay. And you might have seen that in the survey, you have gotten like whether you are okay with sharing, and some people have got whether you're not okay with sharing. And we did that just so we have like both kind of answers. We are not priming you for one kind of response. And then here we got the net. And we see that there are, the yellow, I think is, yeah, people are more okay. And of course, like it makes sense. Like people are okay with sharing their course. Students are okay with sharing their course credits with the registrar's office because someone has to keep track that you are getting a degree at the end of the day. But then, like, for example, third-party services get a massive amount of access of campus facilities access or Wi-Fi location data. And we are often pretty sensitive about it. And then there are different college campuses where there are different amount of utilization of this data, and how we feel about that might, at some point in an ideal world, guide the policies that we develop. The other thing that we did from the question about advantages and disadvantages are the open response, free response comments that we got. We kind of coded them into, finding what concerns or advantages that rose to the top. And we do see, like, for example, the advantages that we all hope to get out of big data and, a massive amount of data collection. In terms of advancement in society, which includes from research, which includes from new companies coming up, new products and services, those products being more personalized, and generally general wealth generation. And while that exists, there are also a lot of disadvantages that we often got to see, and often these came from the same people. I mean, it's not like one group of students who are extremely antagonized to big data and another pro big data or something. It was there exists a very good balance. So there are privacy concerns. There are fear of being manipulated in terms of our behavior being known to big companies or small companies, and they try to control what maybe we want to purchase. And there are, of course, privacy concerns and fear of discrimination that there are some examples that I picked out to talk about. And so this is more or less all from this survey, and we are hoping that after we have enough numbers from this year's survey, we would have a more robust understanding. Hopefully, we will be able to take this survey to other students and see what we learn from all your responses. So thank you once more for taking this survey, and it helps a great deal. And hopefully, I don't know how much of this was new to you, but in a way, I wanted to present this as, you have this unique expertise of being able to develop the tech, shape the future of tech in some sense, like coming from MIT CS department. And sometimes, like, we want to understand, like, we want to bring our own experience of being a consumer of the tech to help us shape the tech that we want to see in the future. And this survey and sharing the results of that is, in a way, an attempt to that. By the way, Nico and others, if you want to share the link to the slide, now is a good point. I mean, feel free to share that so that there are some other articles and stuff that if you want to take a look at your own time, please feel free. So here are some of the interesting developments that I wanted to capture, most of them from 2020. And with the COVID and the political turmoil, 2020 has been a tough year for a lot of us. So and I'm preaching to the choir. If we know that you guys are all very knowledgeable about these topics, so instead of like trying to show like scary things or something, I decided to pick out maybe a pair of things, a pair of articles related to, let's say, one kind of issue, which shows that yes, there are challenges, but there are also promises, or at least interesting developments. And that's something that we need to keep in mind so that we stay hopeful and we do things that we need to do. So for example, we all know that there is a lot of facial recognition that goes on for general people. I mean, you are at a peaceful protest in a rally, or just walking down the sidewalk, and your face is being picked up by many video cameras that exist, and then they get processed, and that data are being like sold to various law enforcement and other places. Just as a citizen, you see that that's there, and that's especially true if you are participating in a protest. Now, thanks to all the technological development that happened, many of these technology has become inexpensive enough, inexpensive as in like, for one person to run in their laptop or some simple setup, that there is this article from New York Times that this activists from Portland who are using that to identify law enforcement, because at some point they were allowed during the protest to cover up their identification. So, you don't really know whether they even are from actual law enforcement. So this activist was using same facial recognition technology to identify law enforcement officials from their Facebook photos and other places. And of course, there is, I am super against doxing, and these could be problematic. So I'm not saying that, this is a slam dunk, this is what one should do, but I'm saying that technologies exist and there are consequences in various ways. And these are things that we hope would inform us in terms of how we develop policies in our society. Second pair of example is this, that facial recognition technology. I'm staying in this because the theme from this year is tag yourself, right? So we don't have to tag ourselves. We are tagged. We are constantly being tagged by everything, and so I picked these examples because these are things that are associated with being tagged and tagging. So this news from NBC. On the left. So this guy spent 10 days in jail because there was a glitch in the facial software recognition. And while that is there, we also have to see that there are various cities, including Cambridge, Somerville, and also San Francisco, Portland. They banned facial recognition tech from being used in law enforcement. Okay, we have a question. What are design considerations and motives that will help ensure technology we build is broadly empowering and democratizing rather than oppressive? That's an excellent question. And that's a question to everyone. And I think it does not have a simple answer. Even if there is one, I certainly don't know. But it's just like we as a democratic society, we need to take up these topics. And the long answer is that we need to educate ourselves about the process, how this happens. So one thing that we learned from the survey last year is that while we know in generality of how this data collection process works and the fact that our data are being collected, the process of that and the extent of that are often unknown to us, even for people who are like fairly knowledgeable about the tech in general, and that includes you and I to some extent. And that's something that is important, because once we educate ourselves, it would be easier to develop, coming up with policies as a society. And there is no alternative to educating ourselves and others. So that's and democratic discussions. I think those are the like debates and discussions, because as we know, like we want regulations. Regulations have sometimes, if there are misguided regulations, they might have stifling effects on innovation. So how we go about those things, how do we achieve a balance? How do we look back at what we have imposed and whether they go far enough or whether they go too far? So this is an ongoing conversation that we have to visit as technology keeps changing. Finally, there are two more. So with the pandemic, now that we are working from home most of the time, that we are studying from home, there are new tech innovations, or let's say more acceptance of tech, which, for example, includes being surveilled at home by the tech that you use. And do we want that? Whether that is productive enough? These kind of questions are things that we should keep in mind, especially as we are thinking about new tech. And this is not from last to last year at this point, but I found this article really entertaining and illuminating in terms of the process of how many of these technology works. And I would highly encourage you to take a look at that. And I really don't know enough to know if the technology has advanced even more from what's described, the process that is described here. But it definitely gives a big, a reasonable layout in terms of the process of a lot of, how tagging works and how we understand our data brokerage landscape. Any questions so far with this? Oops, I don't know. Oh, okay. Let's see. Ah. Okay. So just to recap this whole section, we understand from the survey and from our own experiences that we have a very strong desire for our privacy to be respected, and at the same time we realize that it's not really respected the way we want. So we, and especially you, I'm looking at the participants of web lab, as we are thinking and learning about the tools and thinking about what new products people would want to use and we want people, including ourselves, to use in the future. How do we think about these, and how, for example, we address ethical concerns, which include biases that already exist in the algorithm, or how we apply the algorithms. Of course, a huge question, and I am probably one of the least qualified people to talk about it, is right now all this data brokerage, corporate data brokerage, often that happens as a way of monetization and financing the development of new tech. If that is not there, then how are we going to do that? And that's a big question. I think one thing that we see more recently is the rise of subscription services, which is almost kind of different depending on what services we are talking about. But we also see that there is a falling. This went to the different. Sorry, I'm having some tech trouble. I want to go back to the full screen. Oh no. Oh. Um, all right, I somehow lost the slide presentation. Let's see. Okay. All right, finally back. Oh. Okay, so yeah, so there are big questions about monetization and financing, and of course there have been more and more different privacy regulations coming up. For example, CCPA, which is from California, or GDPR, which is from the European Union, and they sometimes go too far, sometimes probably don't go far enough. And as we are developing new tech, we need to think about these and other upcoming regulations that would come up. And also, we probably want to bring in other policies where it's not adequate and talk about policies that should be changed if they go too far. So I would leave this part of the talk uh, with that. And so with that, I think I would move on to the next section. Before that, if you have any question about this section or the survey, please feel free to chime in. If not, let's talk about the special category prize, which is, I would try to motivate you here that there is a $1,000 prize on it. So, if that's not a motivation, I don't know what is. Well, bigger prize money would have been better, but this is what we start with. And the other reasons are we are all using Canvas apps. We are all using Canvas LMS at MIT. And also you have the expertise and the user experience to get more out of that. So I have like these three main points as to motivate you to do something about it. And of course, you don't have to make something that's like just about Canvas. You can, okay, so let's go back to this other question that I just got. Is privacy legislation a priority in government right now? If so, why? And if not, why not? That's an excellent question. I think it's hard to say if privacy legislation is a priority. It's probably not so much of a priority. For example, we see that there are, for example, Colleen has mentioned that there are like different laws protecting, let's say, educational records. There are health records are protected much more than many other records. Then we see that there are regulations coming from like CCPA, which is California Consumers Protection Act. But on the other hand, at the same time, we don't have any, there is no federal right to privacy. And there have been talks about it, but we don't see that coming up anytime soon. So yes, so there are all these excellent questions that we are all getting to see, and hopefully we should be able to save this. And maybe Nico, I'm looking at you and other staff members of web.lab. Maybe like we can put this as a document somewhere, and it could be useful for all of us to see that the questions that you are asking, and it would be great. We can even put them together and try to find answers to these questions, because honestly, like it would be like, in a way, is the next question. Like once you develop an app out of this, or maybe next year, you might want to take it to the next step. And what do you need to do? Who can use your websites, and below the age of 14, and which country they're accessing them from, and whether you're being GDPR compliant or not. Like, is there like, should that be added as a next module next year? Like that's something that we can think about. And we should be talking about privacy regulation. The downside, as I mentioned, that comes up at times, is that it should not be stifling. I mean, for example, when we barely know how to make the tech, we probably need not start bothering about whether we are CCPA compliant. So that balance is something that we need to think about and we need to understand. But you are in excellent position to delve into this topic because you can develop tech and you understand the importance of these issues as a consumer. So in terms of Canvas LMS, we should see, I'm just trying to break down the different kind of apps that are possible, more like in terms of categories. So one idea is if you are, for example, guided to the individual. So you want to track your own records coming from not just Canvas, but maybe edX and other classes, like other services that you might use. And you as an individual might want to see all of that together. You might want to track your own progress, not necessarily in comparison to others, but something that gives you a more of a dashboard as a student. So something like that you might want to do. There are the other categories, of course. We are going to be stuck at home, and the pandemic has probably changed the nature of how we work from home and how we study from home for forever. So we would probably see a flurry of collaboration apps. So if we are staying the way we are, what would enable us to be more collaborative, be more together with others, even if we are not physically co-located? And since a lot of studying happens via Canvas, how can we use the affordances, the facilities that we have in Canvas, how we connect them? So the third thing is, of course, the educational experience that you're getting, the learning experience that you're getting from your professors, for your instructors. What kind of tool you think that they had access to and they used so that you could learn things better? So these are the broad categories. And here, I think I have a couple of resources. And if you just search, you'll see that there are many other resources that are already available. So the first one is the official Canvas API. And then there are various wrappers available. I'm more like a Python person, and I know that that's not the technology of choice in this more fancy web development course. So but there are like wrappers, various different JavaScript wrappers that are also available. And you can create an access token visiting your users and settings. And you can see some example of apps that exist or that are available to integrate with Campus in the last link, Edu App Center. I'm pretty sure that you can develop much better apps than many of the apps that exist there. So with that, I would say, I'm open to answering your questions about what kind of apps could be good. If you want to, if you have questions during this time, or you develop something and you want to see the possibility of integrating that. There are also questions about, like, for example, if your app wants the username, the authenticated user. So there is this LTI protocol that many learning tools, interoperability protocol that many of the apps use, including Canvas. So that's something that, for example, you can use with edX and Canvas. And there are various wrappers for that sort of protocol as well. So if you have questions about any of these, if you want to run some idea by me, before or after, anytime, feel free to get back in touch with me. Let's see. If you have any other questions, comments, including these chat comments, if you want to add some more, feel free to put them in that Google Forms so that if I have to give this talk again, I know how to improve on that. So I would really appreciate that. If you have other thoughts, go ahead. And also, this is my email ID. If you want to talk about any Canvas apps or anything that, any other topic that we talked about here, I'm available. And earlier I could say, like, oh, just go to Open Learning Office and you'll find me there. Now I can't, but we are all pretty accessible. So That's all I had prepared for today. Thank you so much for joining on this Friday, and good luck with the competition and learning web development. And it's open for questions. If you have questions, just go on.
Yeah, thank you. I know we still have like 15 minutes, and there are some questions in the chat. And if you wanted to get to them, or we can also collect them. But if any other students wanted to also share questions afterwards, they're welcome to.
Yeah. So let me see. So there is a question. I think the legislation priority, I sort of addressed that, and the Fairbairn COPPA. And yeah, who should be making privacy regulation? How should we balance out corporate interests plus money and personal beliefs? That is, that's an excellent question that also ties to the question of how we finance the development of tech. And it's, I mean, I can say my personal belief or something, which is like, we gather a lot of data and we have a way of bringing out good products out of them. At the same time, we have possibilities of harming people. So perhaps we should look carefully where those harms come from and what kind of protections are absent. So for example, if my habits of, let's say, not walking, being sedentary and working on my laptop all day long makes me a bigger target for developing heart diseases later on, and that information is being sold to my insurance provider, that's probably tied to the fact that my insurance can change that rapidly based on factors that are largely outside my control, and maybe that should be addressed separately, and that should be talked about. So there are these kind of, I think, individual aspects of these privacy regulations, but then there's also a push in the civil society in terms of getting more blanket privacy uh, acts, and also separate ideas that would protect people from, like, again, I'm not pushing like that's what it should be, but ideas about, let's say, universal healthcare. Like if people have that, then this is probably not going to affect this. This stops being an issue. Like, sure, I mean, you can find out that I have a greater propensity of heart disease, but if I do get that, then I have healthcare insurance. So these are the kind of balancing act that we have to do as a society, and there are pros and cons for everything. Okay, so I don't see any other question right now. And if that's the case, I would let you all get back to your stuff, and you get 10 minutes of your life back. And but I'm open. Send me an email. You have the slides. If you want to chat about any of these things, I'm open. And Nico, if you want to have these questions put out some more, I'm all for it. And thank you so much to the organizer for organizing this. I really enjoyed preparing for it and seeing you all there, like over 100 people. That's fascinating. Okay.
Yeah. Thank you. Yeah.
Thank you.
Can we all give him like a virtual round of applause?
Oh,
Thank you for joining us.
I'm flattered. Glad to see you all.
Yeah. If anyone missed it, so one of the nice things about WebLab is that we do give out prizes, and so as he mentioned, Open Learning is sponsoring a category prize on Canvas. So we'll make sure to post those details on Piazza for anyone who missed them.
Thank you so much.
Yep.
Okay. Bye.
Thank you so much.
Bye,
Thank
everyone.
you. And I think someone's next. I don't know who's next.
Yeah, I'm not.
Okay, cool.
Maybe it's one set up.
right, today we're going to learn how to code Go. So this lecture is going to be kind of just all over the place. It's going to be a little bit of everything. You can read the slides if you ever just want to like review what I talked about or like reference it in the future. But I'm just going to be jumping around a bunch of things to learn so you can code good. So let's get started. The first thing, don't use Git like a monkey. We have seen many people use Git like a monkey. You do not want to be a monkey. Do not use Git like a monkey. Let me teach you what it's like to be a monkey. So, for example, when you start working, you should do git pull at the beginning. If you don't do git pull and someone else from your team did some changes, you're gonna have merge conflicts. And merge conflicts make me sad. They also make Booga Booga sad. Before you commit, make sure to do git status to check everything that GitHub will push to push online. If you don't check its status, you might just push things that you don't want. We have seen people in the past push their credentials, environmental variables, or even node modules, and you're, in that case, uploading like megabytes and megabytes of data, which is going to make pulling really slow. So just before you push anything, make sure to do git status. An even better thing than git status is git diff. What git diff does is it tells you all the lines that you changed and everything that's going to be pushed. So for example, right here, I know that I added one line saying demo and a link to the demo. And I know that that's everything that's going to be pushed. So if you are overly cautious, do git diff. And another important thing is make sure that it works. If do not push broken code to GitHub, it makes everyone sad. And even worse, if you push broken code to GitHub, sometimes Heroku will automatically pull it and your website will crash. You will learn about deploying in the next lecture. But if you push broken code, you run the risk of your website just crashing. So at least make sure that when you run npm start, it actually runs. So this is a little bit less important, but make your commits make sense. What I mean by this is make sure that every single commit that you make is as small as possible. So it only focuses on one thing. So for example, here, I have one commit that just fixes the auth middleware that I put. And at the bottom, I have something that's a mega commit. And this is bad coding practice because you added a bunch of things in one commit. And if you just want to remove one of them, you're going to have to go back, see the lines in this commit that are relevant to a specific feature, and then push another one instead of just being able to roll back. To avoid having mega commits. And another thing, a couple commands that you should absolutely avoid. This one's kind of contested. Git add period. Many of us use it, but you shouldn't. It is bad practice. What it does is that it adds everything in the current directory to Git. And if you have not run git status before, it will add basically everything. So what you can do to avoid this is set up something called a .gitignore file. And even if you do git add period, whatever file you list in .gitignore will not be pushed to GitHub. You can see the TypeScript skeleton for an example of a .gitignore file, or you can just Google it. They're pretty common. The next one is git push force. Whenever you see force in any GitHub command, be really, really careful. If you use force, I assume you know what you're doing. But most of the time, people don't know what they're doing when they're using force. What force does, it essentially tells GitHub that regardless of how bad what I'm doing is, do it, which is not a good relationship. So avoid this. Same thing with git reset hard. So you have used git reset hard many times in this class, in every single workshop, but that's because we have set up our repo in such a way that we don't care if you delete all the changes that you have made. So what git reset hard does is that it looks at every single change that you made since you pulled, and it just deletes it. And so you have worked a lot of hours, and then you just do git reset hard. You just lost a bunch of work. And this is really sad. Don't do it. Git commit amend. It changes history, and you don't want to change history. It's kind of sketchy. Just make a new commit. And that's basically it for not using Git like a monkey. The next one is going to be about code formatting and style. So you have seen many of people from staff take code like this and then just automatically make it look nice. So the way that we do this is by using something called Prettier. I think Dson made a Piazza post like a week ago about how to make Prettier work. But what it essentially does is that every time that you hit save, it just makes it look nice. It's nice to have. There's only one downside to using Prettier, is that if you use Prettier and your friends or like your teammates don't use Prettier, then you run the risk of reformatting all their code. And you're going to have huge diffs. So just make sure that if you decide to use Prettier, everyone else who's going to touch your code also uses Prettier. Or else you run into like weird merge conflicts just because of formatting. Okay, so that's a little bit aside on just formatting. I think one of the most important ones is writing quality code. So writing quality code is kind of an oxymoron when you have a hackathon or a programming competition that lasts only 1 month. But try your best to write quality code that makes sense. So you're going to run into this scenario, either in this class or in future classes, where you have to make a choice between restructuring your code, renaming files, moving things to make one change. And this will take you, I don't know, 3 hours. Or you could just modify one function and then move parameters a bit, and then add the feature in only 30 minutes. Which one do you guys think is the better way of doing things? Yeah, number 1 is the best way to do things. So the reason that you want to do number 1 is because you want to avoid hacky code. There are cases where you don't want to do number 1, but I'll get to that towards the end of the class, towards the end of the lecture. But if you have a bunch of like hacky code that you keep writing just to add features, your code will eventually become a mess. It will be difficult to understand. Your teammates won't understand what it's doing. You won't understand what it's doing. The staff won't understand what it's doing, or maybe we will after a good hour or so. But hacky code is generally just inefficient code that could be hard to follow, that breaks really easily, or just uses things in a way that they shouldn't have been done. For example, like using get requests in the wrong part inside a component in React. We see this quite a bit, and it leads to hacky code. So the way to like deal with hacky code is to just not have hacky code. And the way that you don't have hacky code is by designing well from the start. So what you want to do, I think there's a Piazza post pinned about this, is that you want to sit down and design how your app will work at the beginning before you like write any code or like even design how the UI will work. What you want to do is like first like make sure like you have wireframes, you have like an idea of what you're making. Afterwards, you want to like break it down into its component hierarchy in React. Then you want to talk about which data you're going to store, how you're going to store it, the schemas that you're going to need, stuff like that. And then you want to write the API endpoints that you'll need. So an API specification is a huge document. It could be a Markdown file. It could be a Google Doc, whatever you think is easier. That just tells people that are using your server or your front end what endpoints you have. So for example, we made a website called Portal that we use to grade students. And we have a huge document that tells everyone in staff, or like at least the people that are working the front end, what methods or what endpoints they can reach. So it tells you the name of the endpoint, what it specs as its body, and what types those parameters should have. The other reason that you want to avoid hacky code is because you're going to spend 80% of your time reading code. Only 20% of your time will be writing code. Whether it's reading documentation, whether it's reading your teammates' code, or even your own code, you're going to spend most of your time reading code. So you want to make sure that the code that you write is easy to understand. Because sometimes, even if it makes sense to you, if it's not easy to understand, your teammates that will try to modify it will not understand it, or will take a lot of time to understand. So the natural question is, what is clean code? So there are classes like 6031 that are going to really instill in you the idea of clean code. And I will try my best to talk about the, I think that link is dead. I'll fix the link after my presentation. But yeah, so there are classes like 6031 that teach you like throughout the whole semester how to write quality code. And I can't possibly tell you every single detail about how to write quality code in the next half hour. But I'm gonna do this. The first one is the dry principle. This one's pretty common. It means don't repeat yourself. If you're ever seeing huge chunks of code being repeated, or even small chunks of code being repeated, it probably means that you gotta abstract it away into a function, or restructure your code in such a way that you don't need to repeat yourself. This is a pretty common code smell to detect, because you can just see how often you repeat code. The next one is having meaningful names. So I'm gonna give you guys a peek into how Buka Buka works. And even though like there's like a lot of implementation details that are like abstracted away in this code snippet, it's somewhat easy to follow what the logic. So if we like read through the function from top to bottom, this function is called setup state refresh. So this probably means that it's a way of like refreshing all the data that we have at some point. Then inside there's a function called run every minute. And without even going into the implementation, I can tell you guys that it's a function that runs every minute. And inside there, I put a function that finds happiness from students, then emits a happiness level, and it throws an error. And it throws an error if you can't find happiness. So the code is pretty simple to understand. And this is kind of like what you want to strive for. There are details right here that could be cleaner. For example, there's no way of knowing that run every minute takes in a function. But because I'm using TypeScript, I can tell that it uses a function as a parameter. If you use JavaScript or something, you want to like add like more documentation about this. But with TypeScript, you can just see what parameters it takes and what the type is, and it's pretty easy to understand what you should put in. So the main idea is to have meaningful names. Meaningful names are probably one of the most important skills as a software developer. If the names make sense, if you can easily name what a function is doing, it's a signal that the function is clean. If you struggle to find the correct name for a function, it's normally a sign that whatever you're trying to do is too complicated, and you should break it down into smaller functions. And that is the perfect segue for my next slide, functions. So functions should be small. They should only do one thing and take as few parameters as possible. So if you ever have a function that is doing a bunch of things, it's making a call to MongoDB, it's writing to Google Cloud, it's emitting a socket event. If you have a function that's doing a bunch of everything, it means that it's really hard to use it correctly, or at least it's really unclean. So you want to make sure that you break your functions down such that they do only one thing. And the reason that you can tell that it's not doing and a way to tell that it's not doing one thing, a pretty obvious one, is if you ever take Boolean parameters, so true or false parameters, it means that there's basically two functions or two things that you're function is doing, depending on a Boolean parameter. And this also means that you should break it down into two: a function that should run whenever that parameter was false, and a function that should run whenever the parameter was true. There's many coding books that teach you how to write clean functions, and there's a lot of debate online about what a clean function is. But the main idea is to have like very small amount of code inside a function. You have very few parameters. The optimal is 0, but it's very hard to get 0 parameters for everything. So you can use 1, 2, 3 is pushing it, but there are cases where you need to use 3. 4 is seldom the right thing to do. If you have 4 parameters, actually your code might need a little bit of restructuring. But there's probably a case where you need 4. Okay, so stepping back from functions, another important thing about functions is that they work. It's very important. If your code doesn't work, then regardless of how clean it is, we're not going to use it. And the way to verify that it works is to test your code. In this class, we will not expect you to ever write tests. Testing is cumbersome, and testing takes a bunch of time to get right. Most likely, the best thing you could do without spending a lot of nights coding tests is to just load your site, work through all the UI things, make sure that everything renders correctly, and then do everything a user will be able to do, and just make sure that it works. So this is kind of just user testing. If you want to write unit testing, there are libraries like Mocha and libraries like Jest that will do this for you. And how they look, it's kind of like this. So I wrote tests for Buka Buka just because Buka Buka is over-engineered. And there's like 15 tests that run. And testing just makes me feel safe. So what testing does is it runs GET requests or POST requests to every single endpoint that my server has. And then I can say what kind of status code I was expecting or what kind of response I was expecting from the server. And it just runs it for me. Instead of having to run npm start and npm run hotloader, I can just run npm test, and it will test every single endpoint that I have. And they do fancier things. Like right now, it's telling me every single file or every single line that was rendering the test. And it tells me which lines I didn't test. So right here, I tested 82% of lines, which I think is pretty good, but it could always be improved. But yeah, you can talk to me about setting up tests. I feel it won't be too hard. If you come to office hours, I can help you set up testing. But then again, this is not needed. This is just me because I want to over-engineer things. For the competition, you just kind of want to walk through your code, open your website, and make sure that it works. Oh, another thing on this vein is that when writing endpoints in your server, don't expect the front end to be nice to you. We will look at your front end and back end code and see if there's ways to break your code. So for example, let's say you have an endpoint that changes the name of a user, and it takes the ID of the user and then the name that they should have. If you're expecting the front end to pass the right ID, someone that has some malicious intent or just wants to mess with your site can just put the ID of another user and change their info. So you want to make sure that the user that's making the request is the same user that you're modifying. This is kind of a very simple one. But in general, don't expect the front end to be nice. Don't expect your function to be called with parameters that you just expect to be in the right form. Also, a fun fact, you can make tests run automatically in GitHub. It's called continuous integration. And I wrote continuous integration for Buka Buka. So whenever I made a push or a commit, it ran a bunch of tests and it ate up all our the GitHub hours or whatever it is. So we had to shut it down. It was really sad. Okay. So stepping down from testing, let's talk about consequences of janky code, aside from not being able to understand what's going on. So I alluded to something called code smell. So code smell is the ability to understand, to like detect code that is Yankee. And this is an ability that you kind of gain over the years or just by coding a lot. But to start off, one of the things that you should be looking out for is copy and paste of code. Do not copy and paste code from Stack Overflow. It will most likely not work, or even if it works, you won't understand how it works. So it's a bad idea. Again, functions that are too long, lines of code that are way too long. Dead code. So dead code is code that just doesn't run, that you never call, or files that you don't even touch. To just avoid, if you ever see any of these in your code, it means that there's something sketchy happening in your code. Okay, so assuming that like for some reason there's a bunch of hacky code, you wrote this at 3 a.m. the day before milestone was due, and to be honest, that was probably the best choice. I'd like you guys to sleep. If it's 3 a.m. and you guys can write hacky code, just as long as you fix it at some point. The reason that you want to fix it at some point is because hacky code creates something called debt. So for example, let's say you start up the project, you download the skeleton, and because our skeleton code is perfect, you have 0 technical debt. And then you start adding features. And the feature is a beautiful feature. It works correctly. It has even no parameters. It has short functions. It's a beautiful feature. But then you want to change it a little bit. So you add a quick hack to add a new feature on top of that feature. And you have a little bit more technical debt. And then further on, you add another feature. And this is, again, a beautiful feature. It's coded correctly. You go to web.lab to office hours, and we tell you that it's a beautiful function. But then you write another hack on top of it. But now to make sure that feature 1 works with feature 2, you got to add an extra hack in the middle. And then as you're adding more and more features, everything is glued together through hacks. And your technical debt just keeps going up and up and up. And when you get to 100% technical debt, it means that you cannot make any more features, because adding any more features is really complicated, because you gotta like add more hacks and more hacks. And it just keeps breaking. So when you reach 100% debt, you gotta start paying it off and paying it off until you have a somewhat workable short code. And as a fun fact, the amount of time that you're gonna be spending paying the debt is much more than the time that you would have taken to just not need hacks at all at the beginning. So this is the reason that you'll want to spend 3 hours making quality code instead of just implementing it quicker and only takes half an hour. So after you pay your enough debt, you're still going to have hacks, or you can spend a bunch of time getting rid of the hacks. But as a main idea is that technical debt accrues interest, just because the complexity of your web app gets exponentially more complex with the number of hacks that you have. So just write good code from the start. And a question that you're probably going to have is it worth it? And is it worth it is kind of a hard question to answer for all cases. My personal opinion is that it's all worth it. However, I can see where there are cases where it's not worth it. So again, it's 4 a.m., the day before milestone 2 is due. Your code is not running. You can either have good coding practices and spend another 3 hours trying to fix it, or you can just spend half an hour, put a hack, and make the website work. I would say that in this case, it's much easier to just add a hack, make it work before the milestone is finished, and then worry about it the next day. It's kind of like a balance between deadlines, sleep, stuff like that. If you're ever losing sleep over code, please don't. I did this a lot as a freshman for web.lab. Don't do it. It's fine if you have a hack. Again, this class is basically a long hackathon, especially towards the last 2 weeks. You're gonna like start writing hacky code because you need to plug code, and I understand that. So just make sure that you keep your depth in check. Okay, so now moving on from the whole like hacky code, clean code topic, let's talk about comments. So comments are normally helpful. However, they sometimes can be too helpful. So let's say you wrote code in 2 different versions. Which one would you guys prefer, the left or the right? Yeah, good point, Daniel. The right one is much more readable. The reason it is that there's such a thing, such as over-commenting. Over-commenting is normally like writing comments about things that are obvious. So for example, if we read the left, this is a route. This route is a GET request for the user. I can tell that it's a GET request because of the word GET. And I can tell it's for user because it has the word user. And like same idea with all the rest of the comments. Like do nothing afterwards. I can see that you have nothing or that you're doing nothing. You don't have to write a comment about doing nothing. And again, you're going to be spending 80% of your time reading code. And having a bunch of comments in your code is going to make it harder to find the right line of code that you want to read. So another thing about over-commenting is that if you got to write huge paragraphs about how your code works, it means that your code is also unclean. The best code doesn't need comments. And there's people online that will like disagree with us. But if you write clean code, the amount of comments that you will need are minimal. There are cases where it's hard. For example, right here, this probably needs comments to figure out what's going on, right? I have no idea what like headers are or what headers the headers variable even has. I have no idea what operation 3 is or operation 1, 2. So even though the code has like minimal code, it doesn't really, it's really hard to read. So some people are going to add comments to this and say like operation 1 gets images from Google Cloud, operation 2 pulls the user schema from Mongo, operation 3 adds everything to the database. I don't know. The better thing to do here will be to just rename the variables. This is an example of bad naming. Instead of adding comments, make the names more obvious. There are cases where no matter how good the name is, you still need a comment. For example, this is normally when you are you're using a third-party library, and you got a link to the docs to make sure what parameters you can use. This is a good use of comments. Yep. So for example, this is the code we've written, the code that we saw before, but with actual good naming. And this doesn't need comments. And I know exactly what each function is doing. Cool. So after talking about like writing code, now I'll talk about debugging. Debugging is something you're going to do a lot. And Kai told you guys how to like debug a little bit a couple days ago. But in general, you want to use the Chrome developer tools or the Firefox developer tools and the terminal console logs to figure out bugs. So for example, let's say we have this bug that we are not rendering the profile data, even though we're logged in and even though we went to the right URL. So what you should do is open the terminal window and open the console logs inside Chrome and figure out what went wrong. So right here, the browser console has an error with the GET request. There's no error in terminal, and there's no error with Webpack. So this kind of tells us that the error was in the GET request, and we couldn't get the user. And it tells us what GET request we were trying to do. So the next step to do is to go into the server that checks for this endpoint, and then just print out the data that you're getting from the front end. So the relevant thing here seems to be the query that you're putting and maybe the user ID. So if we print this out, we're going to see that even though user ID is there, the field that we're looking for is undefined. And we're getting nothing back from Mongo. And right here, the bug is that user ID is spelled differently in the query, and the field that we're trying to get is all lowercase. Fun fact, TypeScript will not let you do this, but vanilla JavaScript lets you do whatever you want to do. So this is a common source of bug, just misspelling parameters. Again, if you like wrote like API documentation, you could probably figure out what's going wrong. So the fix to this will be to like rename it, and like with that it'll work. Another thing to check, if you ever want to like figure out what part of your code gets stuck, or even if some part of the code is running, use console logs. There are more powerful things like debuggers and like React developer tools and a bunch of things.
Hello.
I have always stick.
Oh God.
Okay. I've always stick to like console loggers. It's just more natural for me. So just print out variables, print out just like random words, figure out where your code is getting stuck. And the next topic is to avoid writing a bunch of code at once. So imagine you write 500 lines of code, you open your front end, and it's just blank. It just doesn't even show up. At this point, it's really hard to figure out what exactly went wrong, mostly because the more lines of code that you write is the more amount of time that you're going to spend debugging. So instead of writing 500 lines of code at once and then trying it out, what you want to do is make small changes, then go through your front end, check that change worked, and then move on to the next change. You want to like make sure that every time that you write an endpoint or every time that you add a UI component, you go to your front end and make sure that it works correctly. And there's things, and for example, NodeMon makes this really easy because it will automatically recompile your code. And another thing for debugging is make your friends or your teammates look at your code. Even though it could work, there are a lot of bugs that could go unnoticed, and they may show up the moment that your web app is being deployed or right near the deadline. So what you want to do is like make sure that everyone, or at least someone else in your team, understands how your code works. So if you want to be really fancy about this, you can make everything into branches and then just submit PRs and make other people review the PRs and like go all be extra. And this is what I did for 6170. But you don't need to do branches. You don't need to do like pull requests and stuff like that. But as long as like your teammates know how your code works, they look at your code and make sure you're writing quality code, it's going to decrease the chances that you have bugs. The more people that you look at your code, the better it is. So in summary, git responsibly, limit the amount of hacky code that you write. Write code that doesn't need a lot of comments, have a tight debug loop, and don't push more features until you have fixed the bugs that are currently in your app. And yeah, I had a little bit of extra time. So if you guys have any questions or anything else that you guys want to talk about, I have an extra 4 minutes. Or we could just pass it to, I think, D-Sun.
I think it's actually, is it time for lunch break?
Yeah, I was going to say,
Oh.
I think it's lunch first, and then we'll be back.
Okay, cool.
Alrighty, it's 3:05, so I think we're gonna get started. So welcome back. Hope you guys had a nice lunch. This is going to be our very last content-filled lecture for WebLab, so that's really exciting. With that said, let's jump right into it. So today's class is on deployment, and the question is, you've made this project, right? You worked on this website for a long time, and you have this really cool tool, but now what? What are you going to do? Well, you want to be able to share it with the world, right? You want your tool to be able to be accessible by everyone out there who wants to use it. So that's why we do deployment. We need to deploy our website so that we can share it with other people. If someone wanted to use your website before you deployed, they would have to go to your GitHub. They would have to git clone, npm run start, npm run hotloader in order to see your tools. That's, I think, a little bit convoluted for most people to be able to access your website. You want to give them a really nice way to do that. So we're going to deploy. We're going to make our web app easily accessible to the world. And really what deploying is, conceptually at a high level, is we're just getting some other process to run our server.js. So basically, you can kind of think of it as there's this machine out there somewhere that's running server.js. It's doing npm run start. It would be nice if we could just npm run start on our computer and just have it running. But there's problems with that. Our computer is going to run out of battery, and the server is going to die. Our computer is going to lose connection to the internet. So you want it to be running somewhere where it's consistently available for clients to connect to. And now anytime wants to access your website, they can visit the URL that you assigned for your client. So instead of going to localhost 5000, they would go to the URL that you assigned when you deployed. All right, sweet. So that's just a really quick high-level overview of what deploying is. And for the rest of today, we are going to be doing a walkthrough of what deploying is like practically. So together, we're going to deploy Capbook React onto a website. You should try to follow along if you can. With Capbook React, you'll be able to do most of the things that I'm going to do today, except for one very small step. If you're feeling ambitious, maybe you can try following along with your skeleton code, right, with your actual project repository, and that way it'll be deployed already. And we're just going to deploy our website together. One quick note is I'm not going to be doing it live. It's going to be screenshots in the slides. And the reason for that is because I find it pretty hard to imagine that you're just going to remember this, all of this stuff by yourself. So it'll be here for reference. When you're actually deploying your website, come back to these slides, walk through the steps, and just do it for your actual website. Deploying is going to fail a lot of the time. If you look at this meme, 60% of the time, it works every time, which is very true. It's not going to work your first time. I can almost guarantee that. So you want to be able to deploy long before your website is due and have a lot of time to debug. So let's try deploying. Let's get started. We're going to be using a service called Heroku. So some of you might have seen Heroku already. Most of you probably. What Heroku basically is it's a hosting platform, a website hosting platform. So it's going to allow us to host our websites. It's going to generally give you a URL of this format. So whatever you named your app here, and then .herokuapp.com. So if you go to that URL, you'll be able to see your website working. And if you want to see Capbook working right now on Heroku, feel free to visit this link. We've deployed a version of Capbook here. Cool. So let's deploy Capbook ourselves. So what we're going to do is go to heroku.com. And you should have an account already. You should have made one in one of the homeworks from the first week, but if you don't have an account, make one real quick. And it'll take you to this dashboard. From there, you're going to click New on the top right corner, Create New App. And that's going to take you to a page like this. So what you've basically done is you've instantiated this new application that Heroku is going to host. What you need to do is you need to give it a name. So I just named it this, but you can name it whatever you want. Maybe like catbook-react-your curve or something. Note that it has to be a unique application name because Heroku, again, is hosting your website at yourapp.herokuapp.com, right? So if you named it the same as another app, it wouldn't know which one to host when you visited the website. So you're gonna have to name it something unique. And let's click Create App. That's going to take you to a page like this. So we have instantiated this application on Heroku, and we're going to want to deploy it. So if we go to this Deploy tab over here on the top, and we're going to see a page that looks like this, and we're going to have to click this button here, Connect to GitHub. So what that's doing is it's telling Heroku, hey, I have this website that exists on GitHub. I want you to go link up with that code over there and just run it and host it. So now your website, which is living on GitHub, Heroku can just read it directly from there and host it itself. All right. Can I just make sure that people are following along so far? Can you just send a quick thumbs up, React, if you're caught up, if everything is making sense? Okay, sweet. Cool, looks good. If this is not making sense, that's totally fine. I think a lot of things are not going to make sense the first time that you walk through them. The first time that we go through it, it's going to be new, right? But that's why there's slides. That's why there's recordings. Just watch it over again when you're going to deploy, and that should help out a lot. All right, let's keep running with this. So after we click Connect to GitHub, if we scroll down, we're going to connect to our web.lab workshops organization. That's where Catbook React exists. And then once you do that, we're going to search for Catbook React and we're going to connect to it. At this step, if you're deploying your actual application, instead of choosing web.lab workshops, you're going to click web.lab-class and then search for the name of your repository there and connect it there instead. All right, and then once we find that, we're going to connect and we're going to click deploy. So what this is going to do is it's going to tell Heroku, hey, I've linked up my app. You can see all the code that you need. Deploy it. Host it at my app name .heroku.com. I want to be able to visit it on the website. So let's click deploy, and it'll take a few seconds, maybe 30 seconds or so. But eventually you'll get to this page. It'll say receive code from GitHub, and then deploy to Heroku is a success. All righty, deployed, right? That was really fast, 10 minutes, and our website is up and running. So why is this a 1 hour lecture? It turns out that deploying is not that easy. So let's actually click on this view button that it gave us, right? So if we click view down here, it's going to open up our application website. And we're going to see that it actually doesn't contain what we want it to contain. It's going to say application error. That's bad. Our website is not meant to be a blank page that says application error. It's supposed to do a lot of cool things. So something went wrong here. Let's try to figure it out. So if we go back to our deploy page for our app, we're going to see that there's this option up here for viewing logs. So whenever you run into an error, when you're running your code locally, like npm run start, npm run hotloader, and something goes wrong with your website page, all your console.logs, all of the things that like could have gone wrong, that's going to show up in your terminal, right? Your terminal is going to probably have some sort of error message like package not found or variable not defined or missing close bracket or something. So those logs from our command line, from our terminal, are going to show up in these logs up here in Heroku. So this is kind of like the output, the logs of running your code. So let's click that and see what's up. So we have all of these logs, just some meta information. And if we zoom in on this section here, we see this line. It says server running on port 3000, and then error, web process failed to bind to port. Okay, what's going on here? Well, if you remember in the code, we had port equals 3000. And that way, whenever we ran our server, it would run on the port localhost 3000. But Heroku is not as obedient as our computer. So we can tell our computer, hey, use port 3000, use port 3000, and your computer is going to be like, okay, yeah, we can use port 3000. But Heroku is going to force a port that your website then has to use. So you can't force Heroku to use port 3000. You're going to have to listen to what Heroku tells you. Heroku is going to tell you, I want to use this port number. And the way it tells you that is it tells you that in this variable right here called process.m.port. So instead of forcing it to listen to port 3000, we have to listen to what Heroku tells us to listen to. And what's going on here is Heroku is basically telling us, hey, I have this thing called .m, or M is short for environment. And I'm going to put some values in there that you're going to need to know about, including this port number. Okay. So for the server, for what host it's running on, it's not always going to be on 3000. It's going to be on whatever port I put in this env variable, this env object. And then you can access it by looking at the port field. So the way to get around it is we can replace our code. In the code, it says const port equals 3000. We can just replace it to this. That's basically going to say, hey, is there a port that Heroku is telling us to run on? If so, we're going to use that. If not, or otherwise, we're going to default to 3000. If your app has not finished building yet, that's fine. Just give it some time. Just keep following along. All right, let's talk more about this env thing. Let's talk more about what it is. So if we go here, let's understand what process.env is. So if we just recap, our app consists of a front end and a back end, right? So the front end, all of this React stuff is going on. It's rendering our website, and then it's calling things from the back end, from the server. So whenever you need to log in, whenever you need to access data from your database, you're going to talk to the server. And the server then is going to reach out to these helper sort of things that exist, like the database for retrieving and storing data, or Google Auth for handling login. Process.env, I like to think of it as another thing that the server, the backend, can talk to. So it's one of those things that the backend can talk to and ask for information. And all it does is it stores some specific variable values, including the port. So to say that another way, process.env is this global variable that our backend can access. We're going to store a lot of values in the process.env, such as port. But also, in addition to port, we're also going to store some other things like sensitive info. And we'll explain why that is in just a bit. But just remember, process.env is this object. It's this global variable that our backend can talk to. It's going to be how our website determines what port to run on, and it's also going to hold some sensitive info for our website. And the reason we want to hide sensitive info in .env is because we don't want other people to be able to see it. So we want to put it in this safe, secure location that only our backend can talk to. All right, so if we remember in our code, we had this one section where we defined Mongo connection URL, and it was this big string that had some sensitive info, right? Like it had our password for a user. So anyone who had this string could theoretically modify our database. So we need to hide this from our code. We're going to put it in process.env. So let's make one. Let's make a process.env file. If you open up your VS Code to the Catbook React folder, we're going to make a file called .env, and make sure that it's going to be in your project's outermost folder. So not inside server, not inside node modules, not inside client. It's in the same level as package lock, as Babel, etc. And we're just going to type in the name .env. All right, and now we're going to add it to our git ignore. So git ignore, I think it's been briefly mentioned before, but just to recap on what it is, it's a set of files and folder names that Git will kind of ignore, right? It's just going to not think about those when doing your git adds, git commits, etc. So in this way, GitHub is not going to be able to track this sensitive info that you put in .env. So again, .env is this object that contains a lot of sensitive info for your backend. And we're not going to allow GitHub to see it. So we're going to put in the git ignore. The way to do that is we open up git ignore. And in addition to the stuff that we don't want GitHub to see, we're also going to include .env. All right, so far so good. The next step is we actually need to put our info in process.env, right? So we made .env. We need to put the information in there that is sensitive. So let's do that. Let's put in Atlas SRV, which is our Mongo connection URL. We're just going to name it something different, but we're going to move that in here. And we're going to also move session secret, which is something that's sensitive, in here as well. So copy over your Mongo connection URL, copy over your session secret into your .env file. These are things, again, that we don't want to put on GitHub in case our project becomes open source. We don't want other people to be able to see this stuff because then they could directly mess with our database. All right, so once you've put your secret information in there, it's gonna be stored there, so we don't need it in our code anymore. We'll get to that later, but just make sure that this information is here. Also, quick note, everyone who's working on the project has to have their own .env file. And the reason is because it's not being put on GitHub in any way, right? So if you guys both want to be able to access this information, you both need to have your own local copies because you can't share it. It's not going on GitHub. It's not being shared. All right, the last step is we have to install some packages in order to access our .env file. So let's install .env by going to the command line, typing npm install.env. And then in order to import the package, we're going to have to require it at the top of server.js. So at the first line or second line of server.js, put this code, require .env.config. And now it's been initialized. We've installed the .env package and we have our .env file. So we can use process.env.variable name wherever we want to use one of those variables that are in .env. Cool, let's see how that works. So in our code before, right, we had Mongo connection URL equals string. We also had session secret over here, hard-coded. These are sensitive pieces of information we don't want GitHub to be able to see. We don't want other people to just be able to see this by opening up our GitHub. So we're going to move them to the env file. So now they exist in the env file under the variable names Atlas SRV and session secret. So instead, we want our code to look something like this. Mongo connection URL equals, and then process.env.atlassrv. What this is doing is it's fetching this process.env object that exists, and it's looking for the variable Atlas SRV and replacing the value of this with that variable. Same with session secret. Okay, so just to go back, it used to look like this with Mongo connection URL equals string and secret is some string. That's sensitive info, we're moving it to the .env, and now we can replace it with this. So now if anyone looks at our GitHub and sees this information, they're not going to know what that Mongo connection URL is, and they're not going to know what our session secret is. This is key for deployment because once you deploy your GitHub, oftentimes you want to make it open source so other people can see it. You want to hide things in process.env. Okay, so we made those two changes. And then just a quick reminder, we were also supposed to make this change. So in server.js, we defined const port equals 3000. We don't want that. Instead, we want process.env.port or 3000. Again, what this is doing is when we're on Heroku, Heroku is going to assign this a value. It's going to modify .env. You can kind of think of it as modifying .env and putting in this port value that we want to use instead of just the hard-coded 3000 value. So those are just the small changes that we need to make. And once we do that, for your actual project, what you would do is you would commit all of your changes, push them, and then we would have to go to Heroku and redeploy. So unfortunately, if you're following along in the Capbook React, so if you're following along in your skeleton code, like your real project, you should do this and just do that. But if you're following along with the Capbook React folder, unfortunately, we don't give you guys edit permissions for that repo. So instead, what you can do is just check out the deploy branch because we just made a custom branch for deploying so that we could see how this worked. And if we redeploy with the deploy branch instead on Capbook React, that should work as well. So either you're following along with your own skeleton code, right? Your own project repository, or you're following along with Capbook React, and then just follow the appropriate steps. Okay, so I'm going to be redeploying the Capbook React repository. So I'm going to switch the branch to deploy, and I'm going to click deploy branch. All right, so the question is this going to work? So what we've done is we've hidden sensitive information into this process.env, and simultaneously, we've given Heroku a way to communicate what port it wants us to run on. So process.env is serving two things here. It's giving us a way to store our sensitive info, and it's also giving Heroku a way of telling us what port to run on. So when we redeploy and give it a second to run and open our app again, it's going to fail again, unfortunately. So it's actually not going to work. The reason is because we've made this .env file locally, but we never pushed it to the GitHub, right? We never pushed it to the GitHub because it's in our git ignore. So Heroku still doesn't know what the value of process.env.atlas_srv is. It doesn't know what the value of process.env.session_secret is. So we need to tell Heroku that, hey, Heroku, you know, on GitHub, there are these secret values that we don't want other people to be able to know, but you need to know it since you're running our website for us. So we need to tell Heroku what those values are. And we're going to do that through config vars. So recap, Heroku does not actually have access to our env files. We need to tell Heroku what they are through Heroku's config variables. This is basically Heroku's version of a env file, .env file. So we have a local version of .env for running code locally. GitHub is kind of the man in the middle who doesn't know what's going on. And then Heroku on the other side, we're going to directly tell it, hey, these are the values in config vars. So if we go back to our app page, we were previously on deploy. Let's move over to settings. So let's click on the settings tab and scroll down a little bit. We're going to see this button here for reveal config vars. So let's click on that. And it's going to open up this sort of menu here. And here we're going to enter the key value pairs. So key is going to be basically the variable name in our process.env. Value is going to be the value of that variable name. And the nice thing here is we actually don't need quotes around the Mongo string, so we should copy it without the quotes. So let's do that. We have two variables in our .env. One is Atlas SRV, one is session secret. So we're going to put those in as the key names and copy over their respective values into the value section. Give you guys a second to do that. All right, hopefully that's done. It should save automatically once you add them. So now, to summarize, we've just communicated to Heroku that we have these values by putting them in the config vars. So now Heroku knows that Atlas SRV is this value, session secret is this value. So .env is your local version, right? It's the local file that you use to run your code and keep sensitive information private. Config vars is the Heroku version. So one of them is your local version, one of them is your Heroku version. All right, so after we're done with that, after we've set the config vars, let's go back and redeploy one more time. So this time, everything knows about everything, right? Our local code knows about the secret values. Our Heroku code also knows about the secret values. So should be able to work. Let's click deploy one more time. And Did that work? Well, let's give it a second to redeploy. Hopefully, after that's run, you should see something like this. So your site should actually work. You should be able to see some sensible code on your site. So let's give everyone a few minutes to just catch up to this point. This is going to be the end of like the follow along section. You're not going to be able to follow for the next step, but let's just give everyone a chance to catch up to where we are. Use the help queue. Staff is going to come help you. If you have any questions that you think would apply to everyone, put them on the questions doc. All right, looks like people are doing okay. So let's move on. So you should get something like this. You have a site that like kind of renders and it works for the most part. But there's one less problem. And that problem is when you click login with Google Auth, it's going to give you this pop-up that says redirect URL mismatch. This might look familiar if you tried following through with the lecture on auth and authentication on Monday, but let's quickly recap what's going on here. So when we set up our website auth with Google, we had to allow localhost 5000 to be a valid website. So that way, Google would know that any requests sent from localhost 5000 are good and not dangerous. And it turns out that we need to do the same thing for when we deploy, right? So when we deploy our site to this app name.herokuapp.com and we try to click the login button, Google is getting this request from a website that it does not recognize. So we need to tell Google, hey, this website's actually okay. Please allow the login request to go through. And the code for doing that, the sort of guide for doing that is here on web.lab.2/client ID. If you did that the first time, let's continue and head over to console.developers.google.com. All right, so once we're here, we're going to look at our project name, which is test deploy in my case, but you probably named it something else. And we're going to click on credentials. And in this part down here, if you remember, we created an OAuth 2.0 client ID for our website. That was the Google client ID that we copied over into our code. So if we edit that, we're going to see that originally it only was allowing localhost 5000 to go through. And we just need to add another valid URL for it to work. So in my case, that would be test deploy xd.herokuapp.com, but in your case, it'll be whatever you just named your Heroku app. So let's add that URL and put it in there and save. And once we do that, Google is going to know, hey, I get a login request from this Heroku app domain. It's valid, actually. I see it, I recognize it, I'm going to let it through. So after that final step, you should basically have your website deployed. It should be working. It should be working online. Everyone should be able to access it. No one needs to clone your GitHub repository and do all the npm run start nonsense. So hopefully that works. Deploying is really a tricky thing because it's really hard to debug. And sometimes you'll need to just do it multiple times for it to work. So we recommend strongly that you guys try deploying your websites a long time before the milestones are actually due, just so you have that buffer time. And also, come to office hours and the hackathon tonight to try to deploy it. Let's just do a quick recap at the very end of all of the steps that we had to implement in order to deploy our website. So first, we had to go to Heroku and link it to our GitHub. Then we had to create this .env file and add it to the git ignore because it contains sensitive information that GitHub should not know about. From there, we started modifying variables in our code from their original value to the value that might be dictated by process.env. So the port number should not just be hard-coded to 3000. We need to give Heroku app an option of telling us what port to run on instead. And we also need to move our sensitive data, such as the Mongo connection string, as well as the session secret, into the .env file. Process.env is this big object that we can call from the backend in order to access these secret variable names. And so once we've moved all of that into the .env file, we also need to make sure Heroku knows about it by putting it in the config bars. And finally, we need to tell Google Auth to allow logins from our new website address. After all of that's done, it's a lot of steps, but after you finish all of that, you can go ahead and click deploy, and your website should be online and available for everyone to see. So, if you made a website by following along, you can share it with your friends. They should be able to just open it up and see like the page of Catbook, or if you deployed your own personal site, congrats, you already have it deployed. There's going to be a lot of errors because deploying is tricky. So if you run into those, just add yourself to the help queue or come talk to us, make a Piazza post. But if you follow these steps exactly, you really should not run into any problems. Cool. Hope that makes sense and you guys have your websites deployed. I'll turn it over to Shannon and Nick for send off when they're ready.
Let's share my screen. Awesome. Nick, you ready?
Yeah.
Okay, cool. This is like the final lecture. It's not technical. This is more so like a generic guide on how you should start and like what we're looking for when if you're trying to get credit or compete. So yeah, this is the How to Win web.lab lecture. And here are some tips that we have compiled because we've taught this class for a while. So here's some of them. You should definitely plan out your web app. And what we mean by this, so we've already set like milestones for you to keep you on track, but I think you'll probably want to set more like internally for you and your team. Like our MVP is due next Tuesday. It's coming up very soon. That's designed to help you stay on track for the final submission. And there's like a lot of requirements for the milestone too, but we front load it so you'll have like less work toward the end because debugging takes a lot more time than you'll think. So just like a brief overview of what we've done in the past 2 weeks together. Like we went through like all of Catbook and created a whole web app together from scratch. So I guess you'd be pretty proud of yourself for following along for that. It's a big task. A lot of things are taught. But let's just do a brief overview of like what we've learned and how like it all meshes together. So for day 1, we taught HTML, CSS, which is your page content, structuring, remember the box model, and design, like how to make your website look pretty. And then we taught like client-side JavaScript, so how to make things on your website move, hooking up with our API calls. We even built our own API, and then hosting your own server, creating like all those different routes and endpoints and like serving pages. And then we also learned about databases toward the end of the first week. Hook that up with MongoDB, and we use like Mongoose to help us make those calls and set up schemas, and that helps us access and edit the data for your website. And authentication, so creating a personalized experience for users requires them to have some form of authentication. So we taught you guys how to use Google Auth. And then we taught like a lot of sockets, React things, that they kind of fly around in this stack. But this is how we design Catbook and how maybe you can be inspired to like lay out the plans for your own web app, because Catbook is a pretty big app. Okay, so we kind of did this like feature by feature. So we decided like what extra things we wanted Catbook to have and decided to implement it like that. And features are usually like full stack, so they go down this little stack here, as you will see. And yeah, so you basically you've probably had this term before, but people are not familiar. Like full stack is just all those layers of the app, like front end all the way down to the server and the database. And yeah, Nick can take it away.
Another big concept is designing your web app like feature by feature. So like working on one thing at a time, just get one thing working and then move on to the next. So we're actually going to walk you through basically how we designed the Catbook profile and like how you might do something like this in your own app. So the main thing with this is you need to first create your wireframes, then build out what the component tree will be in React, then design the APIs, and then design the database schema. That's the high level overview of like how you build every new feature in your app. So as a reminder, the point of the profile is to display some visual information about the user, so we can see what's going on with them. And maybe we drop some wireframes in Figma, and now we want to make the front end for it. So we think what's the point of this front end for this one feature for the profile? And the point is we want to have a visual display of the information. So we ask ourselves like, what do we want to show and how do we want to show it? And that's the point of the front end part of designing the profile. So we've sort of answered that with the wireframe, and we get the look at what it is, and we then have to just create the CSS and the JavaScript in order to display this information properly. Next, on the server side, we then think about, well, how do we actually get that information? What does the client need from us in order to display that information? You can ignore this to-do on the right. That's not relevant for you guys in React. We just forgot to update that slide. So you have to ask yourself, what does the client need? And you realize you need to load in the user's name. You need to load in their About Me section, or I think it's actually just About Me. And then you need to load in the user's cat or something, just a bunch of their information. And the way you would do this is you edit the apis.js file so that you can provide a new user route to get the information. And so you have to just think, well, what do I need in order to get the front end to be able to run properly? And once you've done this, once you have everything, all the API routes you need, you then need to think about the database. You need to think about what information do I need to store so that way I can eventually get it back. And so if you do that, then you have to think about the user schema. And this is just a simple way you might write it down on paper, just like with the name of the schema and a bunch of fields, and just think about like all you need to store in order to actually get that route. So in summary, like in order to do this, you first had to create all these React files and the API route itself and the schema itself. So if you think about this from an even higher perspective and you think multiple features, we have the profile with the front end, as we just saw, the back end and the database. But then when you add in more features, you're going to have other things. You're going to have more components, you're going to have more routes, and you're going to have more database models or collections. So another important thing is that planning will help you really stay on top of your project. It'll make sure that you all know what you're doing and you have a good path forward and are like on track to finish. So Shannon will tell you a bit more about that.
Yeah. So we've talked about like a lot of ways to keep like your quote plan updated, like how to code a good lecture, or like if you use TypeScript. Those are all different ways you can have a plan. But I think the best way is like to make sure you like document your code or like your progress, what tasks you want to work on, what features, and like it should communicate between your team. So make sure like you keep your teammates up to date and that you guys have a clear idea of who's working on what. And if you ever decide to change your website, like you want to create a new feature, or you've decided that you're going to scrap this one thing, or a new bug has shown up, you should probably indicate this in your plan somehow. And
with that, the other important side of planning is that you need to actually communicate with your team. There's not much good in planning if you don't talk to each other, since you guys are working together on this project. So communication can avoid a lot of difficulties, like maybe when you're starting out working on a particular feature, like tell your partners, hey, I'm starting working on this part, so you guys shouldn't, because maybe they've already started and you don't want to accidentally wind up writing the same code twice. That's just a waste of time. So we don't really care how you do it, Slack, Messenger, Discord, whatever. Just communicate with your partners. It'll make your life a lot easier. The other part of that is to divide up the work. This is just a tactic that will make it even easier to communicate with each other, because you don't have to say, hey, I'm working on this one particular thing, because it's already your job. So there's a couple different ways that you can divide this up. You can have just like one front-end engineer or one back-end engineer and like one UI person. And like these are all different jobs you could have, or you could have everybody is working on their own feature. And so you all know to stay out of each other's way when you're working on that feature.
I want to emphasize like things we look for like in a winning website or a semi-finalist is like what makes your app stand out. So I really recommend you focus on like one killer feature of your app, like what makes your app unique and different from the rest. It's better to have like a couple really good solid features than like a bunch of ones that are like really buggy and make the experience not enjoyable. So again, quality is greater than quantity. You've probably heard this a lot, so I don't want to dwell on it. But here's some like examples. Like if you guys have played like Jackbox games before, each game is like pretty simple. They have a pretty simple concept and they execute it extremely well. Like the UI, the in-game experience, it's really good, and they handle like concurrent users really well. And like each game just focuses on one thing. And like this silly game, like it looks pretty cute. Like the UI looks really adorable. and it has like one feature, like raise your magic card to jump higher than anyone else's. But they execute it really well, and it gets a lot of downloads. So it can be something as like simple as this. And you want to make sure that you like use your team's strengths as well. So if someone wants to work on, is like particularly passionate about one feature, they should probably work on that. If someone has a really good eye for design, you should probably let them design like some of your wireframes or the CSS. If someone loves working in the backend, communicating with database, let them do that. But it's a good idea to make sure everyone is working on what they enjoy. So yeah, like example, like Hollow Knight is a good game where their main team strength was the hand drawings, and I like set them apart from the others, and they were able to execute that really well.
Finally, as you're developing your web app, you're going to want to make sure to do a lot of testing. And in this case, I don't mean the same kind of testing Johan was talking about earlier. I mean user testing, because you need to know that your app is actually something that people want to use and people know how to use. So one way to do this is to just go to a friend, or ideally someone you maybe don't know as well, or who doesn't know you as well, and ask them like, what do you think you're supposed to do with this? Give them your app and let them play with it. You can also ask a little bit more targeted of a question, like, try and make the Magikarp jump in this app and see if they can figure out how to do it. Because if they can't figure out how to do it, or they can't figure out what they're supposed to do, then you've probably done something wrong in your UI and your app won't be very useful. However, when you're doing this, you got to make sure to not overload them. Like if you keep asking questions, were you able to do it? What was confusing? What stood out to you? Did you like it? And like, were there any bugs? Like these are all useful questions to ask, but if you just keep on asking them, you're going to overwhelm them and they're kind of going to clam up, or they're just going to repeat your own ideas back to you and not tell you anything new. The whole point of this is really to get an outside perspective, because you as developers will sort of get set in your ways, and like you'll think it's easy to get into a mindset where like, oh, my app is perfect and anyone who criticizes it is wrong. Or to think that like any bugs you see are the only ones there are. So with that, make sure to test with a large group of people. Try and talk to as many people as possible, get them all to try it. Not just your friends or family if possible, but like I don't know, send it around to your friends' friends. Post it on Facebook, let people test out your app. Overall, this is not just like a one-time thing you do. You don't just user test once and then you're done. You have to like write your site, test it some more, polish it up based on their feedback, and then keep doing this over and over again. It's an iterative process to get a good website.
So like, just to reemphasize what Nick said, a lot of times we get like websites where like when we're grading them and we have no idea how to make it do what you want it to do, and we'll like have to email you and be like, what is going on? Because like even like bad UI, if you like play with it a lot because you're the one developing it, becomes intuitive to you. It might not be intuitive to like a first-time user. So you have to keep it in mind. I would always like source new people to try out your app.
Yeah, good point.
Yeah.
If random people don't understand how to use your app, then we won't either, and then we can't grade you.
This is true. Yes. And when you're stuck, because web development is not easy, like you guys learned this in like 2 weeks, it's a lot of work. You should come to us. So things you can try. Piazza, Nick's always up. We don't know when he sleeps. He is dedicated to keeping this 1-minute response time. So is a lot of other people on staff. So I would highly recommend Piazza for like times outside of like office hours or the hackathon tonight. And yeah, so just another reminder, tonight's hackathon is at 7 p.m. Eastern to 1 a.m. Eastern. That is 6 hours. We will be available, all 12 of the staff will be available for 6 whole hours to help you work on your app. And we used to have a lot of food and beverages in past non-COVID years, but there will still be generous help from staff. We highly recommend you come. This is the last time you can get live help from us, like to get in person, virtually, I guess, before milestone 2 is due on Tuesday. Like other than that, you would have to rely on Piazza for any other requests. And with that, good luck. It's been a pleasure teaching all of you. And here are some last reminders. I already said it once or twice, but I'm gonna say it again. While someone is doing like less than 4 days, and we will close the form at 6 ET. You should try deploying this the day before. I would not recommend you do it like right before the deadline. Dan has shown us there's many things that can go wrong with deployment. So do not deploy right before the deadline, because like once you deploy it on Monday, you can just keep pushing your main branch and hitting that deploy button again. But I would make sure that works early on. And tonight there's a hackathon and gather. And I think you guys are pretty familiar with the process. So you're gonna wanna go and help queue and like, submit a ticket. Instead of putting like your breakout room, just put your name. I would put your name and your team name in your gather room. So we set up a space on gather to, oh my God. Okay, just for the hackathon tonight. So I'm just gonna demonstrate how that works. Let's let it load. Okay, cool. So you're probably gonna spawn somewhere in this space. We will not help you in these big spaces because it's easy to get interrupted by random people spawning in this space. So you should go inside the hackathon. And this is I would not go in here because it's a staff only. But you go in the hackathon and we set up like tables for you guys. These are all like private spaces. So if you're in this table, only people on this like carpet can hear each other. So I'd recommend you like kind of like plan the space for your team. And these are Claire put some lovely pictures, bad looking pictures of everyone. But yeah, this is so it's easy for staff to jump around because breakout rooms are kind of a pain. But make sure you change your name to like have your team name in it, and we can probably just like locate you in this room. There's a lot of people, like you can't find a table, which I don't know will happen. You can just go to like one of these lounges, like 1, 1.5, 2, 2.5, and we'll find you. But yeah, this is the TLDR gather, and that's all I have. We're probably just gonna end class early unless you have questions for us, which is why we just have hang out with web.lab staff. We'll probably stick around for the next like 20 minutes or so. If you guys don't have any questions you want to ask us or anything. But yeah, Nick, do you have anything?
Nope, have fun. And yeah, please come to the hackathon. It will be very fun and very codey.
Yeah, if you don't want to stick around, you guys are free to go for today. We figured it'd be nice to let you guys out early because there's a 6-hour hackathon.
Can we use the gather now if like we want to do a team meeting?
Yeah,
feel
why
free
not?
to jump in the gather like and just claim one of the tables now.
Should we stop the live stream?
1 second, yeah.